And so the area that I was studying was advanced capacitors. Right? So essentially capacitors that have an energy density exceeding that of batteries. Because they have a very high power density, but a low energy density.
Yeah.
We have a lecture to that effect.
Oh yes, yes. No, we should do that. We'll get it later. But yeah.
Exactly. Obviously, if you could make a capacitor that had anywhere near the energy density of a battery, and with this incredibly high power density and its quasi-infinite cycle and calendar life, then you would have an awesome solution for energy storage in mobile applications. Yeah. So that I was going to sort of work on that and try to leverage the equipment that was developed for advanced chip making and photonics to create ultra-precise capacitors at the molecular level.
And this is when you were going to go into grad school?
Yeah,
you had a brief stint at Stanford.
That's right.
At a PhD in applied physics?
Applied physics, material science.
Right. This is what you were, so even then you were thinking of kind of trying to do something in the space.
Well, actually this was to work on energy storage solutions for electric cars.
Yeah.
And I'd actually worked at a company in Silicon Valley called Pinnacle Research, which did advanced capacitors. There were electrolytic capacitors, but the problem, and they actually were pretty good. They had like the energy density of a lead-acid battery, which for a capacitor that's a big deal. But they used ruthenium tantalum oxide, and I think at the time there was maybe like 1 or 2 tons of ruthenium mined per year in the world. So it's not a scalable solution. Yeah. But I thought there could be some solid-state solution, say using chip making equipment. That was going to be the basic idea. But it was one of those things where I wasn't sure if success was one of the possible outcomes. And it's difficult to bound that problem exactly and say, okay.
So you're saying I felt like this was a destined failure, is another way to parse that sentence. But anyway, so.
No, I didn't think it would fail, but I wasn't sure that success was a possibility.
Okay, yes.
And generally, you want to embark on something, it's desirable to figure out if success is at least one of the possibilities.
Right, exactly.
Because for sure failure is one of the possibilities.
Yes.
But ideally you want to try to bracket it and say success is in the envelope of outcomes.
Yeah.
And I wasn't quite sure if that was the case. I think success on an academic level would have been quite likely because you can publish some useless paper, and most papers are pretty useless.
We have a few. Don't take offense. Sorry.
I mean, how many PhD papers are actually used by someone ever? No,
that's a good point.
Percentage-wise, it's not good.
Yeah.
So it could have been one of those outcomes where you add some leaves to the tree of knowledge.
Yeah.
Okay.
Yeah.
And that leaf is nope, it's not possible.
Right. Right.